Alright, diver, leaping from the edge of a diving platform. That's exciting. This is 2009, number 3, by the way. And, let's see. The figure above shows the initial position of the diver and her position at a later time t. At time t seconds after she leaps, the horizontal distance from the front edge of the platform to the diver's shoulders is given by x of t, and the vertical distance is given by y of t. It's all measured from her shoulders, apparently, where x of t and y of t are measured in meters. Suppose that the diver's shoulders are 11.4 meters above the water when she makes her leap. So that's like saying at time 0, y equals 11.4, right? And I guess at time 0, her leap wasn't. I think that x is also 0 at that time, right? That's sort of certainly what it looks like. It looks like the initial is a 0 there. And if you're in physics, then you might note that this is actually pretty a good model for this, right? dx dt, that's the x velocity, that would be constant, right? And then this, you can see the acceleration of this is negative 9.8, that's the acceleration of gravity. And what would this be? That would be her initial upward velocity, right? dy dt at 0 is just 3.6. All right, so advantage physics. So suppose that there's she makes her leap, and that this and this for where a is the time that the diver's shoulders enter the water. Okay. Find the maximum vertical distance from the water's surface to the diver's shoulders. So that's the maximum of the y function, right? So when does that happen? That happens, let's see, looking for a piece of paper here. Hold on. Oh, there we go. That's good enough. For part A, the maximum vertical distance, that's the same as the max height, happens when the vertical velocity, or in other words, dy dt, is equal to 0, right? That's when she's going to have positive velocity and then negative velocity. So the maximum height happens when dy dt is equal to 0. So let's see, solving that, when does that happen? That happens when we just plug 0 in and do some baby algebra there. That's just 3.6 divided by 9.8, which happens at t equals 0.367 seconds. We do have units in this problem, meters and seconds. And that's the time, so we want to know what that vertical distance is. Well, we need to find the antiderivative of this. You can do this with your calculator, but I'm going to, in the spirit of doing good physics here, we have the y prime, which is velocity, right? So if I take the antiderivative of that, the antiderivative of that is going to be 3.6t minus 9.8t squared divided by 2, or in other words, minus 4.9t squared, plus c. And how do I find the c? Well, I know that at time 0, and we know that this is the antiderivative of this gives us the position function. At time 0, the c is 11.4. Right? That should look like a kinematics kind of equation if you're in physics. And now we just need to plug in, so y of 0.367, or you could graph that and find the maximum, I suppose, if you want, is equal to 3.6 times 0.367 minus 4.9 times 0.367 squared plus 11.4. And that's equal to 12. 0.061 meters. So she started here and she went a little bit higher, about, let's say half a meter or so, and then she starts to go down from there. That seems like a pretty reasonable answer. Okay, part B. Find A, the time that the diver's shoulders enter the water. So when do her shoulders enter the water? I've got a position function now, so since seeing that I have that, I just want, this is the position, so I could just set that equal to 0. 0.6t, 4.9 t squared. I guess I should have graphed it for the last part. That would have made things a little easier now. So I'm going to go to y equals, I'll get this stuff out of there, and graph this 3.6 minus 2, and then we're interested in when that crosses the x-axis, or the time axis really, and how long do you think it's going to take? Probably not more than 5 seconds, and we only care about where it crosses, so a little bit less than 2 seconds it looks like. Let's find that 0, which is in between 1 and 2, at 1.936 seconds. I say 1.936 seconds. C, find the total distance traveled by the diver's shoulders from the time she leaves from the platform until the time her shoulders enter the water. And that is going to be, total distance traveled is the integral from 0 until the time when she hits the water, the square root of dx dt squared plus dy dt squared. I guess I'll do that on the home screen. You have options. You can graph things, right? But, so I'm going to go math 9 fn int of the square root of 0.8 squared plus 3.6 minus 9.8x squared, and then close the square root sign, comma x, comma 0, comma 1.936. That should give me the total distance traveled. 12.942. 12.942 meters. And that makes sense that this is the highest point, so she went up to that point down and she moved forward a little bit, so it makes sense that it's a little bit bigger than that number there. And then part D, I'm going to find the angle theta in between 0 and pi over 2 between the path of the diver and the water at the instant the diver's shoulders enter the water. Well, again, this is a little easier if you're in physics, I think, but it's the angle that we're looking for is, the angle that you're actually traveling at is the angle of your velocity. So we want to know what is her velocity, and then we'll turn it into a little vector triangle, and we'll find this angle theta. So we just need the components of the velocity here, and then we can do tangent inverse rise over run. That's the way to go here. So the this component is always 0.8, right? And this component, when she hits the water, is 3.6 minus 9.8 times the time when she hit the water, which we found is 1.936. That's negative 15.373. That's her downward speed. What we just found is this is her her horizontal speed is always the same. That's the 0.8 that they gave us, and we know the time now when she hits the water. So her downward speed is this, and we want to find that angle there, right? That's this angle of this little right triangle here, and they only want a positive version of that angle, so that's just tangent inverse rise over run, using a little SOHCAHTOA trick. So tangent inverse of 15.373 over 0.8, and I imagine it's going to be pretty close to 90 degrees. It's theta is 1.519 radians. Right, and we could do that again just to see in degree mode. Yeah, it's 87 degrees, so it's pretty close to, but they asked for it in radians. That makes sense, right? You hit the water almost going down, but you still have a little forward velocity, so not quite straight down. All right.